In this lecture, we'll be doing solving question number 131 to question number 136. So from question number 131 to question number 133, there basically we'll learn new kind of formulas. Okay, what are central forces, what are conservative forces. So those are more or less, just remember the formula and get it. Okay. Question number 133, 134, 135, 136. Not 133, 134, 135, 136. They are very conceptual in nature. So learn to see what's being applied out there. Question number 134, 135, and 136. Okay.
Okay. See, one thing you have to learn about potential energy. That change in potential energy is nothing but negative of work done by a conservative force. Okay. Change in potential energy is nothing but negative of work done by a conservative force. So I can easily say that change in potential energy is equals to negative of what is work done, dot product of force and displacement. So from this diagram or from this equation, I can easily say that du by dr or negative of du by dr is nothing but the force. Okay. So out here in this question, potential energy is given as a function of displacement, okay, or r, and they are asking find out the value of r naught such that equilibrium position of the particle. That means find out the value of r naught where the net force is equals to 0. Whenever you hear the word equilibrium, okay, equilibrium is equals to 0 or total force is equals to 0, total force acting on the particle is equals to 0, total torque acting on the particle is equals to 0. Okay. Now there are three kinds of equilibrium. First one is stable equilibrium. Stable equilibrium. Second one is unstable equilibrium. And the third one is neutral equilibrium. Okay. See, whenever there is the word equilibrium, okay, the first necessary condition is net force is equals to 0 or du by dr is equals to 0. Du by dr, which is equals to negative of force, is equals to 0, du by dr is equals to 0, and du by dr is equals to 0. So whenever there is the word equilibrium, okay, net force is equals to 0. This is the first condition of equilibrium, any kind of equilibrium. The second condition is for stable equilibrium, d square u by dr square should be greater than 0. For unstable equilibrium, d square u by dr square should be lesser than 0, and for neutral equilibrium, d square u by dr square should be equals to 0. Now let's focus on the question. In this question, okay, energy, potential energy is given as a function of displacement, a by r square minus b by r. Okay, or I can write this as a r to the power minus 2, a r to the power minus 2 minus b r to the power minus 1. Okay, b r to the power minus 1. Or now see, now you have to find out the value of r at which the net force is equals to 0. That means equilibrium happens. Okay, so if I differentiate du by dr, or if I differentiate this entire term with respect to r, what do we get? We get negative of force. Okay, so therefore negative of force, which is equals to du by dr. Okay, or I have to differentiate this entire term with respect to r, so I get minus 2 a r to the power minus 3 plus b r to the power minus 2, okay, is equals to 0. For equilibrium, the force should be equals to 0. So if I take this entire two equation, I can easily find out the value of r. Or see, b r to the power minus 2 is equals to 2a r to the power minus 3. From these two equation, I simply took this one. I'm solving for this equation. Okay, minus 2a r to the power minus 3 plus b r to the power minus 2 is equals to 0. Okay, and I have taken this term to the right hand side. Or out here, r to the power minus 2 and minus 3 would get cancelled and this become r to the power minus 1. Okay, or r to the power minus 1 is equals to b by 2a is equals to r to the power minus 1. Okay, or 1 by r, or r is equals to 2a by b. So the value of r naught for which the total forces become 0 or the equilibrium position is achieved is equals to r naught is equals to 2a by b. Now the second part of the question you have to find out, examine whether this position is steady. That means examine whether this position is in stable equilibrium. Stable equilibrium. Only in stable equilibrium the position will be steady. No, if you deviate it from stable equilibrium, it will return back to its original position. Okay, unstable equilibrium, if you disturb it, it will fall back. Neutral equilibrium, if you disturb it, it will stay wherever you have disturbed it. Understood? So now you have to find out whether this position is in stable equilibrium or not. How do I find it out? I have to double differentiate this one. Okay, so I have to again differentiate this term with respect to r. So d square u by dr square, which should be equals to, I have to differentiate this term with respect to r. So it's nothing but 6a r to the power minus 4 minus 2b r to the power minus 3. Okay, now what I have to do is I have to put the value of r is equals to 2a by b in this equation and check whether the value is positive or negative. If it is positive, then it is in stable equilibrium. If it is negative, then it is in unstable equilibrium. And if it is 0, then it is in neutral equilibrium. So in this equation, I have to substitute the value of r, or 6a. See, the same equation, 6a r to the power minus 4 or 2a by b. I have to check at this value, no, to the power minus 4 minus 2b r, 2a by b, 2a by b, okay, to the power minus 3. Okay, or out here is equals to 6a b by 2a to the power 4 minus 2b b by 2a to the power cube, or 6a b to the power 4 by 16a to the power 4 minus 2b b cube by 8a cube. Acha, out here a and a to the power 4 would get cancelled to become a cube. So out here this is nothing but a cube, and out here b and b cube would become b to the power 4. So this b becomes b to the power 4. Okay, now if you add these two, see, if you add these two, you would get around, see, this can be written as, see, 2 by 8 can be written as 4 by 16. You multiply the numerator by 2 and denominator by 2. So this can be written as 4 by 16, 4 by 16. Now just subtract these two. Okay, 6b square by 16a cube minus 4b to the power 4 by 16a cube. So 6 minus 4 is nothing but 2b to the power 4 by 16a cube, or 1 by 8, or b to the power 4 by 8a cube. Now I have to check whether this value is positive, negative, or 0. See, out here a and b are positive constants. In the question it is given. That means b by a is always positive and 1 by 8 is already positive, no? So this entire term is greater than 0. That means the body is in stable equilibrium. Understood? Now part B of the question. Find the maximum magnitude of attraction force. Okay, I have to find out the maximum value of force. Okay, draw the plots of potential energy versus R and force versus R. Okay, the equation of potential energy is nothing but this one. and the equation of force or negative of force is nothing but this one. So in physics, whenever you have to find out maximum or minimum, we just differentiate and make it equals to 0. Okay, so for maximum force, df by dr should be equals to 0. Okay, and what is df by dr? That means, see, if f is equals to negative of this value, df of dr, df by dr is nothing but I have to differentiate this term with respect to r and multiply by negative. So if I differentiate this term with respect to r, what do I get? I get this term only, no? We just have to multiply it by negative. Why? Because minus f is equals to this term. So df by dr, or which is equals to minus of this entire term, okay, 6a r to the power minus 4 minus 2b r to the power minus 3 is equals to 0. Okay, I have to find out the value of r at which force is equals to maximum, or df by dr is equals to 0. So if I take this one, or if I take this one to the right hand side, okay, 6a r to the power minus 4 is equals to 2b r to the power minus 3. R to the power minus 3 and minus 4 becomes minus 1. Okay, okay, 2 becomes 3, or 3a r to the power minus 1, or 3a by r is equals to b. 3a by r is equals to b, or r is equals to 3a by b, or r is equals to 3a by b. Okay, now to find out the maximum value of force, we have to substitute r is equals to 3a by b in the equation of force. Okay, out here at r is equals to 3a by b, we get the maximum value of force, and from the previous equation you already know negative of force is nothing but this value, or force is nothing but 2a r to the power minus 3 minus b r to the power minus 2. Okay, so it is, our force is equals to 2a by 3a by b into cube minus 3, okay, plus b r, or 3a by b to the power minus 2. Okay, or f is equals to 2a b cube by 3 3 is 9, 9 3 is 27, 27 a cube plus b into b square by 9a square. Okay, so if I cancel out the, this becomes a square and this becomes b cube. So it is nothing but maximum force is 2b cube by 27a square plus b cube by 9a square, 9a square. Okay, see, out here in this equation I can multiply the numerator by 3 and denominator by 3. So 3b cube by 9 3 is a 27a square. Okay, or which we get 5b cube by 27a square is the maximum value of force. See, the second part of the question is find the, or draw the graph of ur. The equation of u is given by this one. Okay, so at r is equals to 0 we have infinity, we'll get minimum value of r at some point. Okay, and at r is equals to infinity we get the potential energy to be 0. At minimum value of r, or r naught, okay, we get equilibrium, that means net force is equals to 0, and r naught was nothing but 2a by b, r naught was nothing but 2a by b. Check what was the equilibrium obtained, r naught is equals to 2a by b. Now the question also says us to draw the force versus R graph. So force versus R graph, the force will be 0 at R naught. Okay, this is the equation of force. At R is equals to 0, it will tend towards infinity. Okay, and at R naught it will have this value, and it will have a minimum value at how much? Sorry, maximum value at R is equals to how much? 3a by b. So at R is equals to 3a by b, it will have a maximum value. R is equals to 3a by b. Okay, this is the graph of force with respect to R. Now some of you might say that this has to be minimum value. Why are you saying maximum value? See, negative is nothing but, if you see the out here, okay, attraction force. Negative is nothing but out here attraction force, no? And you'll understand this. This is a concept of nuclear physics. Okay, this graphs is generally seen during nuclear physics. So out here, the maximum value of force is obtained. Okay, this is the graph of forces to R. This part is not that much important. Okay, if you know, it's well and good. If you don't know it, you can leave this one. Okay. Pay attention to this question. This question is very conceptual in nature. Okay, out here potential energy is given as alpha x square plus beta y square. So how is this potential energy different from the potential energy given in the last question? The one thing that is different out here is this potential energy is given in two-dimensional manner. The last one was alpha r to the power minus 2 plus beta r to the power minus 1. Okay, which is one dimensional in nature. But out here our potential energy is two dimensional in nature, x axis and y axis. So how do I convert this potential energy to force? From the previous problem we do know that minus du by dr is equals to force, no? Okay, or you differentiate potential energy with respect to displacement, you get force. But how do I get the force vector? See, whenever potential energy is given in terms of x, y, and z, okay, the simple rule is minus d, the entire potential energy, alpha x square plus beta y square, okay, by dx, I cap. That means whenever you're differentiating the potential energy with respect to x, treat everything else as a constant. Okay, minus d by dy, and potential energy alpha x square plus beta y square j cap minus d by dz alpha x square plus beta y square, okay, into k cap. This is the value of our force. Okay, so when you differentiate this x is nothing but minus 2 alpha xi. Okay, if I differentiate this term is nothing but minus 2 beta y, minus 2 beta y, okay, j, and out here this entire term would be 0 because there is no component of k, which is equals to force. Okay, so out here you got the value of force or vector component of force. Now the first part of the question is find out whether this field is centered or force is centered. Field is nothing but force on one unit. Okay, so we'll learn this in gravitational chapter, that concept of forces and fields. For right now, whenever you hear the word field, field is nothing but force on 1 kg. Sorry, not force on 1 kg, force on 1 unit. Gravitational field is nothing but force on 1 kg. Electrostatic field is nothing but force on 1 coulomb. Magnetic field is nothing but force on 1 unit of north pole or south pole, or 1 unit of magnetic pole. Okay, magnetic this strength. Okay, so find out whether this force is central. What is the meaning of central? The meaning of central is, suppose this is the origin. Okay, central forces is usually those forces where the vector at any point, see, this force is given as a terms of x and y, no? So at any values of x and y, if you see the vector, okay, the vector should always be pointing towards origin. Okay, vector should always be pointing towards origin. And how do I know that all the vectors for all values of x and y, all the vectors are pointing towards origin? How do I mathematically derive that? Okay, see out here. For any point, assume any point x comma y. Okay, out here. See, let this be a Cartesian coordinate. Okay, this is the origin. Assume any point x comma y. Okay, now what is the r vector? R vector is nothing but xi plus yj. This is the r vector. So this force, okay, if you input this value of x and y in this equation, okay, if the force point out towards the origin, then the field, then this equation is said to be central field. And how do I ensure that happens? See, what is the angle between r and f? The angle between r and f is 180 degree for every central field. Be it out here x and y. If you input this value of x and y in this equation, the force will point towards origin. So r vector is this one, force vector is towards origin. So the angle between r vector and force vector will always be 180 degree for any values of x and y. Okay, so can you see a point out here I'm making? R cross f would always be equals to 0 for central vector. So make a note, for central vector, for central vector, central vectors r cross f is equals to 0. Why? Because the angle between r and f should always be 180 degree. Okay, now let's put out the values. What is r cross f? R cross f is nothing but I j k. What is the value of I? R x y 0. What is the value of force? Force is nothing but minus 2 alpha x, minus 2 alpha x, minus 2 beta y, minus 2 beta y, and 0. Okay, so the value of, see out here, this value is nothing but plus I cross x into 0 minus 2 alpha into 0 minus j, this one, x into 0 minus 2 alpha into 0. Okay, so the only part remaining would be the value of k vector. Solve this determinant by yourself. We'll see only k value would remain. Okay, and k value is nothing but x into minus 2 by, x into minus 2 by, minus of y into minus 2 alpha x, y into minus 2 alpha x. Okay, if I simplify this, k vector minus 2 by x, and this minus would become plus, plus how much, plus 2 alpha yx, 2 alpha yx. Okay, and for this value to be central, r cross f should be equals to 0. Okay, so I component and j component is already 0, the k component should also be 0 for the field vector to be 0. Okay, so out here minus 2 by x plus 2 alpha yx is equals to 0. Let's check if this happens or not. Okay, so we need to learn the relation between beta and alpha. Is there any relation between alpha and beta given other than a and b are positive constants? So I cannot say no b is equals to a out here. So if b is not equals to a, this may or may not be equals to 0. So this cannot be equals to 0. Okay, cannot be equals to 0. So it depends upon the relation between a and b. So unless a alpha is equals to beta, Okay, the fields are not central. So out here the fields are not central, not central. Why? Because we don't know the relation between alpha and beta. If in the question it was given alpha is equals to beta, the field would out here would be central. Okay. Now the second part of the question is what is the shape of equipotential surface and also the surface for which the magnitude of the vector force is equals to constant. Okay. Now this value of force, the magnitude of this force should be constant. Okay. So F is equals to, let's do the second part in second slide. Okay. The question in the second part is asking what is the shape of equipotential surface. My first question is what is the meaning of equipotential surface? The meaning of equipotential surface is surfaces in which all the points in the surface have same potential energy are called equipotential surface. Okay, all points in the surface have same potential energy, have same potential energy. That means if you move around the surface, change in potential energy is equals to zero. Okay, equipotential surfaces are those surfaces in which all the points in the surface have same potential energy. Okay, so out here what is the formula for potential energy or what is the equation of potential energy? U is given as alpha x square plus beta y square. Now to find out the equipotential surface, I must know that this potential energy must be a constant or is equals to, let's say, constant C1. So alpha x square plus beta y square is equals to C1. Now how does this or what is the equation of this plane or what is the surface equation of the surface? To which surface does this equation belong? See, if you learn mathematics, the equation of ellipse is given by x square plus a square plus y square by b square is equals to 1. So suppose there is a ellipse. Ellipse is a 3D surface. Sorry, 2D surface, not 3D surface. Sorry. Yeah. Okay. Out here, the length of major axis is given by 2a and the length of minor axis is given by 2b. Okay. So somehow I see the similarity between this equation and this equation. How? See out here. Can I write this as alpha x square by c1? I'm dividing the c1 from left hand side and right hand side plus beta y square by c1 is equals to 1. Okay. Can I take alpha to the denominator? Of course. Or x square by c1 by alpha plus y square by c1 by beta is equals to 1. But out here a square is given, so no parameter of square is there. So I'll just under root it and whole square it, under root it and whole square it. So this became a equation of ellipse by the semi major axis. Okay, where a is equals to how much? A. Okay, a or a is equals to how much? Under root of c1 by a, under root of c1 by alpha. Similarly, b out here in the ellipse is given by under root of c1 by beta. Okay, so this is the first part of the question. And the second part of the question is also find out the surface, also find out the surface for which the magnitude of vector of force is constant. Okay, what is the equation of force? This value. What is the magnitude of force? The magnitude of force should be nothing but I square or minus 2 alpha x whole square plus 2 beta or plus minus 2 beta y whole square under root. This is the magnitude of force. Now the question is asking this magnitude of force is constant. Okay, find out the equation of a plane, or find out the equation of a surfaces in which throughout all the points in the surfaces the magnitude of force will remain constant. So out here this is asking, the question is asking, this is the magnitude of force, minus 2 alpha x whole square plus minus 2 beta y whole square. This is the equation of magnitude of force. The question is asking, find the equation of a surface, okay, such that all the points in the surface has same magnitude of force, similar to potential energy. Okay, so out here this is some constant. Okay, because the magnitude of this force should be constant, no? That is what the question is asking. See, so out here, can I remove this square root and make it square out here? Okay, see, and this would become plus, because anything, any negative sign under a square becomes plus, it doesn't make a difference. Okay, out here, 4 alpha square x square plus 4 beta square y square is equals to C2 whole square. See, now even this equation looks like ellipse. How? See, I'm just dividing by C2 square. Okay, C2 square, and out here C2 square. So this entire term would become 1. This entire term is 1. Now can I send 4b square to the denominator? Okay, so I'm sending 4b square to the denominator and 4 alpha square to the denominator. So divided by 4 alpha square divided by 4 beta square. Okay, now see, what is the value of a? The value of a is nothing but c by 2a. I can rewrite this as c by 2 alpha, no? C by 2 alpha whole square, or c by 2 alpha whole square, and this as c2 by 2 beta whole square, c2 out here also c2 by 2 beta whole square. So out here this surface will also form an ellipse, but in this ellipse the a, or the length of semi-major axis, is nothing but c2 by 2a, c2 by 2 alpha, and length of semi-minor axis is nothing but c2 by 2 beta. Okay, semi-minor axis is, sorry, semi-minor axis is nothing but this length, and semi-major axis is nothing but this length. Okay, now one more question I have: does this potential have a single equipotential surface, or a single surface where all the potential energy is same? No. See, suppose the potential energy out here is 5 joule. There will be another potential or another surface where the potential energy throughout the surface is equals to 10 joule. There will be another surface where the potential energy throughout the surface is equals to 15 joule. So although I'm increasing the potential energy while I'm changing the surface, the potential energy throughout the surface would be the same, no? Okay, so what will happen? The value of this constant would change, but something would remain constant. The ratio of semi-major axis to semi-minor axis, or major axis to minor axis, would always remain same. See, if I make this ellipse a little bit bigger, the ratio of major axis to minor axis would always be same, no, for equipotential surface out here. So all the surface, okay, in which the ratio of semi-major axis by semi-minor axis is equals to under root of c1 divided by alpha divided by c1 divided by beta. Okay, c1 will get cut, and it is nothing but beta by alpha, beta by alpha. So all the ellipse, okay, in which ratio of semi-major axis to semi-minor axis is under root of beta by alpha will be equipotential surface. Okay, the value of c was nothing but a specific equipotential surface. Okay, if we increase the value of 2a, sorry, if we go outward, okay, out here there will be another equipotential surface, okay, but the potential energy is different. but the potential energy throughout the surface or throughout this bigger ellipse is same. Similarly, out here C2 also plays the same role. So suppose C2 is a ellipse, okay. Out here all the magnitude of the force is equals to same. Out here 5 Newton, out here also 5 Newton, 5 Newton, 5 Newton. But if I make this ellipse a bigger something, a bigger ellipse, out here all the points in the ellipse will have 10 Newton of force. Okay, 10 Newton, 10 Newton, 10 Newton, 10 Newton, 10 Newton. But what will remain constant for equipotential surface? Oh, sorry, not equipotential surface, a surface having same force. A by B would be C2 by 2 alpha divided by C2 by 2 beta. Okay, 2 gets cancelled, C2 gets cancelled, or A by B is equals to beta by alpha. So surfaces which have the same forces is nothing but they are in the ratio of beta by alpha. The semi major axis to the semi minor axis are in the ratio of beta by alpha. Okay, we'll learn this concept. See, most of you have done, I think, electrostatics. So most of you might understand what are these equipotential surface I'm talking about. Okay, even if you don't understand, I'll introduce briefly about equipotential surface in the next chapter of gravitation. Okay, but right now just understand up till here it was mathematics. Okay, it was physics. After that, then onwards we have entirely mathematics. This has nothing to do with physics. Okay, this entirety is mathematics. Now see this question. Okay, there are two forces. F1 is equals to ay I cap and F2 is equals to, let's write this, force 1 is equals to ay I cap and force 2 is equals to ax I cap plus by j cap. Okay, where I and j are unit vectors along x and y axis and a and b are constant. Find out whether these fields are potential. Okay, what the question is asking is find out whether this force 1 or force 2, okay, is conservative force. The simplified form of question is find if F1 or F2 or both of them are conservative force. Conservative force. Okay. Asha, you all know many things about conservative force, have done in the theory, but the mathematical relation of conservative force is nothing but. So how do I find out the mathematical relation of conservative force? You first need to understand a term called this one. Now, Lux, what is this one? Whenever you see a inverted triangle, no, in physics, that means nothing but a vector d by dx I cap plus d by dy j cap plus d by dz k cap. This inverted triangle is means nothing but this vector. Okay, and this vector is used in multiple occasions throughout physics. See, some of the conditions are, this is a vector quantity, no? Okay, sometimes it will be multiplied by a vector or dot product with a vector. Okay, suppose a force vector. Sometimes this vector would be a cross product with a vector. Okay, so this symbol is this vector. This vector represents this symbol, and we use multiple times this symbol or this in physics. Okay, now how does it have to be related with conservative force? Okay, whenever any force is there, okay, suppose any force is there that is expressed in terms of x, y, I, j cap. Okay, the necessary condition for the force to be conservative, okay, forces are conservative when this vector, okay, this vector cross the force. That means cross product of this vector and force is equals to 0. Okay, this is the necessary condition for, or this is the mathematical condition for conservative force. Okay, this is the mathematical condition for conservative force. In the language of physics, this is known as curl of force F. Okay, So let's check with F1. Our first force is F1. I have to check whether this force F1 is conservative. So what do? We cross this cross F1 is equals to 0 or not. Okay, I check it. I, j, k cap, the first vector, d by dx, d by dy, d by dz. And what is F1? F1 is nothing but ay I cap 0, 0. Okay, so I have to check this one. Or if I solve for the determinant, what do I get? So if I solve this determinant, this value comes out. So day by dz. Okay, so out here there is no term of z out here, so everything is constant out here, so this becomes 0. Okay, out here day by dy is nothing but the a comes out, or this is nothing but a k cap. Okay, whenever you do partial differential, okay, remember that suppose you are differentiating with respect to y, every other term other than y, okay, be it a, be it z, be it x, okay, suppose I'm differentiating with respect to y, every other term other than y should be treated as constant. Similarly out here I'm differentiating with respect to z, every other term apart from z will be treated as constant. So out here only ak remains. I have to check whether ak is 0. So a is not 0, so this or curl of force F1 is not equals to 0. Okay, therefore F1 is not conservative, not conservative force. Okay, not conservative force, or cannot be stored as potential energy. Now I'll check for force F2. Divergence cross F2. Okay, similarly make the determinant out here. When I make the, so I've written the cross product in determinant form. Okay, this one is nothing but d by dx, d by dy, d by dz, and ax by 0, ax by and 0. So when I solve this determinant, what comes out is, see, see, when I solve the determinant out here, okay, I cap into d, see, 0 multiplied by anything is 0, minus of d of by dz, d of by dz, minus j cap to forward this line. Okay, this into 0 is 0, minus of, which I forgot a minus, minus of dAx by dz plus k cap out here, cross multiply d by dx, d by dx minus of dAx by dy. So when I solve this one, see out here in dz there is no term of z out here, so this differentiation is already 0. There is no term of z out here, so even this differentiation is 0. There is no term of x out here, so even this differentiation is 0. Okay, there is no term of y out here, so even this differentiation is 0. So curl of F2 is nothing but 0. So this F2 vector or F2 force is a conservative force. Conservative force. That means this force can be stored as a potential energy. Okay. The mathematical condition for conservative force is curl of force is equals to 0. In physics, we call this symbol curl of F. Okay. And some additional information that might be used later. Okay. The dot product of any vector with this symbol is called divergence. Okay, this is called curl of force F, this is called divergence of force F. Now this question is fairly simple. There is an inclined plane at an angle alpha. Okay, a block of mass m initially has velocity v0. Okay, the coefficient of friction is given as mu. The question is asking what distance will the body cover before it stops? That means the friction will stop the body, no? So find the distance L in the plank till which the body goes. Okay. Acha. When the body stops, what is the final velocity? The body stops when velocity is equals to 0. So can we apply work energy theorem? Change in kinetic energy is equals to work done by all the forces on the body. Okay. What is final kinetic energy? 0. What is initial kinetic energy? Minus half mv naught square. What are the forces doing work on the body? There are only two forces that is doing work on the body. First one is the friction force. The second one is the gravity force. The normal force doesn't do any work. Okay. Why? Because displacement is always perpendicular to the normal. So out here work done by gravity force, okay, is nothing but mgh, where h is the height till which it reached. Achha. Can I write this h as L sine theta? See, L sine alpha is nothing but h. H is nothing but L sine alpha. L sine alpha. Okay. And the work done by gravity is positive or negative. It is going upward. Gravity force is acting downward. So displacement is opposite to the direction of force, no? So it is negative work of gravity. And the coefficient of friction. What is friction force out here? K. Instead of using K, okay, I'll be using mu. So it's better to understand. Mu mg cos alpha. That is the value of friction force. And you have to find out the value of L. L is the distance traveled before it stops. Now let's solve this equation. Minus half. I'll just solve this equation quickly and tell you. Okay. Out here minus and minus, all the minus would get converted to plus because I'm cancelling out the minus and I'm cancelling out the m. Okay. Now let me take the L common from both of them. I'll take L common. Okay. So L out here, L out here. And I'll take G also common. G. So G out here, G out here. So you get the equation half V naught square is equals to GL sin alpha plus mu cos alpha. And we need to find out the value of L, or L is equals to V naught square by 2 G into sin alpha plus mu cos alpha. That's the answer. Okay. Now the second part of the question is, what is the work done by friction force? So work done by friction force is nothing but friction force, which is equals to mu mg cos alpha into displacement. Displacement is nothing but L. V naught square by 2g sin alpha plus mu cos alpha. Okay. What I did out here is work done is nothing but force into displacement. Okay. Displacement is nothing but given by L out here. Okay. Out here work done by friction force is negative, no? Because friction force is acting opposite to the direction of displacement. Okay. Now what I do out here is I take this cos theta and divide by denominator out here. Okay. So sin alpha by cos alpha plus mu cos alpha by cos alpha. So I'll get the answer somewhat like this, or is equals to, okay, what I did out here was I took this cos alpha and divided it out here and out here. Okay, so we get this answer. Now in this question, okay, a body slides down out here and goes through a projectile out here. Okay, this surface is frictionless. The question is asking, find the relation between h, small h, and capital H such that the value of this s is maximum. Okay, so first I need to find out what is the value of s. So for that, to find out the value of s, I need to assume something. Let me assume the velocity v out here is equals to v. Okay. Now I don't know what is the velocity. Now my main objective is to find out the s in terms of this velocity. Okay. So this is nothing but projectile from an elevated surface. So y component is nothing but, I'll just do s is equals to ut plus half at square. S is equals to ut plus half at square. Okay. Initial y component is equals to 0. S is equals to h. Okay. A is nothing but g. So h is equals to half gt square, or t is equals to 2h by g under root. So time taken for this ball to reach out here or to fall down is equals to 2h by g. So the time taken to fall down is equals to time taken to travel distances. So x component. Okay, I'm applying s is equals to ut plus half at square. In projectile, the horizontal acceleration is 0. So this entire component would be 0. Achha. U is nothing but v. This is given in the question. See, v is given in the question. And this is horizontal. By diagram, we understand that this velocity is horizontal to the surface. Okay. What is the value of t? The value of t as obtained in previous equation is nothing but 2h by g. Okay. So s is equals to v into under root of 2h by g. Fair and fine. Now the ball started from here, no, and reached out here. Okay. So first I need to find out the what is the velocity in terms of capital H and small h. So can I say effectively this height, this height is nothing but capital H minus small h, because capital H is the entire height, small h is the nothing but the smaller height. Can I apply work energy theorem between these 2 points? Of course I can apply. So if I apply work energy theorem for the particle between these 2 points, I'll get final kinetic energy, that is half mv square, minus initial kinetic energy, that is out here, which is equals to 0, is equals to work done by all the forces. What is the only force that is doing some work out here? Gravity force. The normal force is doing 0 work out here, and there is no friction force. So work done by gravity is nothing but mg capital H minus small h. Okay. Or half mv square is equals to mg capital H minus small h. M and M would get cancelled, or v square is equals to 2g capital H minus small h. Achha. Or v is equals to under root of 2g capital H minus small h. So if I substitute this value of v out here, I get the value of displacement as, I'm copying this value out here. Okay, s is equals to v. V is nothing but under root of 2g capital H minus small h, okay, into under root of 2h by g. Okay, so I can simply multiply these two terms under a single square root. So just remove this square root and bring this under a single square root. Okay, so g and g will get cancelled, or s would become under root of 2 to the 4, 4h into capital H minus small h. Okay, 4h into capital H minus small h. Under root can be written as to the power 1 by 2. Okay, now I need to maximize this value. Okay, so whenever in physics maximum or minimum comes up, we just have to differentiate and make it equals to 0. So with respect to what do I have to differentiate? What is the only variable out here? The only variable out here is small h, no? Okay, so for maximum s, or maximum value of s, ds by dh should be equals to 0, or I have to differentiate this function with respect to small h and make it equals to 0. Okay, just before differentiation, Let's multiply this 4h by capital H and small h. Let's multiply this 4h inside the bracket. Okay, so it will become 4 into capital H small h minus 4h square to the power 1 by 2. Now I have to differentiate this entire term with respect to small h. So if I differentiate this entire term, ds by dh is nothing but half this entire term 4 capital H small h minus 4 capital H square. I am applying chain rule to the power half minus 1. Half minus 1 is nothing but minus 1 by 2. Now I go into the bracket or inside the bracket into 4 capital H minus 8h small h. Okay, which should be equals to 0. For maximum, ds by dh should be equals to 0. So obviously if this term is equals to 0, ds by dh, the entire term comes to infinity, because minus 1 by 2 will go to the denominator, no? So the only remaining option is this term should be 0, or 4h minus 8h should be equals to 0. So out here 4 capital H minus 8 small h should be equals to 0 for h to be maximum. We cannot make this term 0. If this term becomes 0, then this entire terms become infinity. Check, minus 1 by 2 means if this term goes to the denominator, and anything divided by 0 at denominator is nothing but infinity. So our only option is making this term equals to 0. So this term is equals to 0. So out here h is equals to capital H by 2. Okay. So the maximum distance, okay, maximum distance the particle will cover when s is equals to capital H by 2. That means this distance is equals to capital H by 2. This is capital H by 2 and this is capital H by 2. Let's erase this one, capital H by 2. Okay, half of. Okay. The second part of the question is asking what is it equals to. That means what is the maximum display, or what is the maximum value of s equals to. The maximum value of s is equals to nothing but 4 into this value. Okay, where small h is to be substituted by h by 2 or capital H by 2. So s is equals to, I'm seeing this value. Okay, okay, 4 into capital H into h by 2 minus 4 into capital H by 2 whole square to the power 1 by 2, to the power 1 by 2. Okay, if I solve this one, okay, or s is equals to h square, 2h square. Out here h and h will become h square, 2 and 4 will get cut to become 2 minus 4 h square, h square. Okay, see, 2 square will become 4, this 4 and this 4 will get cut, and h will become h square. So h square to the power 1 by 2, to the power 1 by 2. 2h square minus h square is nothing but h square. So h square, and h square to the power 1 by 2 is nothing but h. So this entire term is, so the maximum value of displacement out here is nothing but h. Okay, see, what happens if we make this h much larger? The velocity out here, the velocity out here would not be sufficient, because the work done by gravity would not be sufficient. So it will fall much lesser. What happens if I draw or make h to be very less? Okay, if h is made very less, the velocity, the horizontal component of velocity is very high, fair and fine, but the time taken to drop would be very less, so the projectile wouldn't go that far. Understood? So the age optimum for maximum value of s is nothing but s, small h is equals to capital H by 2, and the value of s maximum is nothing but h. Okay, in this question there is a ball out here. Okay, it is left out here and it rolls down this surface, and at this point it enters a semicircular arc. Okay, so as it goes up to the arc, at certain point in the arc it will leave the arc. No, why? because it does not have sufficient velocity to keep in contact with the earth. Okay, it will leave at some point in the earth, then it will follow a projectile motion. It will reach the maximum height of h and then come back or strike anywhere at any point out here. Okay, the question is asking find the point, okay, or find the velocity of the body during which the ball breaks the contact from this circular arc or semicircular arc. Okay, find the velocity of this body out here. Okay, so this body or this ball will break off contact out here with certain velocity, let's say velocity v. Acha, what is the number one condition for breaking off contact? The normal contact forces should be equals to 0. So this is the circular arc. Okay, the body, acha, instead of drawing the arc, let me just draw the ball. Okay, this is the object. The normal contact force would be in this direction or along the radius. Okay, normal contact force. Let the velocity be v. Velocity is tangential to the semicircular arc. The radius is given as h by 2. Fair and fine. Okay, are there any other forces acting on this body? Yes, there is gravity forces mg acting on this body. Are there any other forces? No. So let's component these gravity forces along the normal and perpendicular to the normal, or along the tangent and along the normal. Okay, so this force or this diagram can be written as velocity v along the tangent, this velocity v along the tangent. Normal contact force should be passing through the center. Why? Normal through any circular or spherical objects always passes through the center. Okay, let this angle be theta. Let this angle be theta. So out here this was mg, no? If this was mg, let this angle be theta. Okay, so in this direction it is mg cos theta, mg cos theta, and in tangential direction it is mg sin theta, mg sin theta. Okay, what is the value of normal contact force during breakoff? The value of normal contact force becomes 0. So out here there are two kinds of acceleration. One is tangential acceleration and the other one is centripetal acceleration. So right now we're not interested in tangential acceleration, so we'll deal with centripetal acceleration. Net centripetal force or net normal force is equals to mg cos theta is equals to mass into normal acceleration or centripetal acceleration. So out here m and m gets cancelled. Centripetal acceleration can be written as v square by r is equals to g cos theta. Okay, what is the value of r? The value of r given in the question, see, the value of r given in the question is nothing but h by 2. Okay, r is nothing but h by 2. So out here v square is equals to h by 2 g cos theta. Okay, this is our equation number 1. I simply took this h by 2 and send it to the left hand side. Okay, now I can do one more thing. Can I apply a work energy theorem between this point and this point? Okay, work energy theorem means change in kinetic energy between this point and this point is equals to work done by all the forces between this point and this point. Okay, so when I'm applying work energy theory, before applying work energy theory, I have to find out what is this height or what is this height. Okay, this entire height. Okay, this much height is nothing but h by 2. Why? Because this is the radius of the circle. So this much is h by 2. Fair and fine. How much is this much? How much is this much height? See, if this angle is theta, okay, if this angle is theta, see, theta, theta, this line and this line makes a 90-degree angle. So this is nothing but 90 minus theta or theta dash. Can I write this line as h by 2 or radius sine theta? or h by 2 sine theta dash. Okay, h by 2 sine theta dash. Sine theta dash is nothing but sine 90 minus theta, and sine 90 minus theta is nothing but cos theta. Okay, so h by 2 cos theta. So this entire distance is nothing but h by 2 plus h by 2 cos theta. Okay, so effectively I need to find out one more distance. This distance minus this distance, x. Okay, why am I finding out x? Because see, gravity is a conservative force, no? So from here to here, work done by gravity would be mgh, and from here to here, work done by gravity would be minus mg into this side. So effectively, work done by gravity is nothing but this side mg into this side minus this side. Okay, so this side minus this side is nothing but x. So I'm directly finding out x. X is equals to how much? H minus h by 2 plus h by 2 cos theta. Okay, if I take h common, x is equals to h. Okay, 1 minus 1 by 2 plus 1 by 2 cos theta, or cos theta by 2. Okay, if I open the bracket, if I open this bracket, if I open this bracket, okay, I'm opening this bracket. 1 minus 1 by 2 is nothing but 1 by 2. So this is nothing but 1 by 2. And can I take 1 by 2 common? Okay, so h by 2, h by 2, 1 plus cos theta. So let me write it neatly. H by 2, 1 plus cos theta. 1 plus cos theta. Okay, now I need to find out, or I need to apply work energy theorem between this point and this point. So at final point, what is the velocity? V. What is the kinetic energy? Half mv square. The change in kinetic energy or final kinetic energy, half mv square, or kinetic energy out here, minus initial kinetic energy. What is the initial kinetic energy out here? 0. Why? Because the body starts sliding. Starts sliding means initial velocity out here is equals to 0. Therefore, initial kinetic energy is equals to 0. Is equals to work done by all the forces. What are the forces acting on it? Normal force. The work done by normal force is equals to 0. Because at every point, normal force is perpendicular to displacement. Friction force. Friction force is acting throughout the surface. Okay, and gravity force. So work done by gravity force is nothing but mg into x, or mgh minus mg this side, which is equals to mg x. Okay, so I can write it as half mv square is equals to mg into, what is the value of x? H by 2, sorry, h by 2, 1 plus cos theta, or m and m would get cancelled, 2 and this 2 would get cancelled, or v square is equals to gh 1 plus cos theta. Okay, this is equation number 2. So if we solve equation number 1 and equation number 2, we'll get two values, the value of v and the value of cos theta. I made a little bit of mistake out here. Okay, this problem is nothing but 1 minus cos theta. It would be minus out here. See, simplify this one. H minus h by 2 minus h by 2 cos theta, no? So after h by 2, if you take common, it will be 1 minus cos theta. So out here, if we just draw this, it will be 1 minus cos theta, not 1 plus cos theta. Okay, out here it will be h 1 minus cos theta. Okay, so rectify this simple error. So now we have two equations and we have to solve for v and cos theta. So if I equate v square and v square from equation 1 and 2, what do I get? Gh 1 minus cos theta is equals to gh by 2 cos theta. Gh and gh would get cancelled, or 1 minus cos theta would be equals to cos theta by 2. Okay, if I send minus cos theta to the right hand side, it would become 1 is equals to cos theta plus cos theta by 2, which is equals to 3 by 2 cos theta, or cos theta should be equals to 2 by 3. So this is the first answer. Okay, now you can either substitute this cos theta value in this equation or in this equation, both will have the same result. So I need to find out the velocity. So I'm substituting this cos theta in equation 1. V square is equals to gh by 2 cos theta. Cos theta is nothing but 2 by 3. So V square is equals to gh by 3, or V is equals to under root of gh by 3. Okay, see, now question is asking what is the velocity at topmost point. So let us study the projectile of this body. Okay, this will go down and will reach out here. Out here it will break off contact, okay, with velocity v. Now this velocity v is tangential to this semicircular arc, is tangential to the semicircular arc. After breaking off point, it will follow a parabolic path and hit somewhere out here. Okay, it will follow a parabolic path. Okay, fair and fine. The maximum height of this parabolic path, or maximum height of the body during its entire motion is equals to h. Why? Because gravity is a conservative force and no non-conservative force is acting out here. Friction is not there. Okay, and normal contact force doesn't do any work. Okay, so out here at a maximum point in the projectile, okay, what is the total velocity? Can I say after breaking off contact it will follow a projectile motion, no? And in projectile motion the horizontal component of velocity is always constant. Okay, so at maximum height the value would be horizontal component of velocity. So I need to find out what is the horizontal component of velocity. So out here I have already taken this angle as theta. Okay, I need to find out the velocity component of velocity along this horizontal line. See, this line, horizontal line and vertical line makes a 90-degree angle. So if this is theta, this is nothing but 90 minus theta, or theta dash. Okay, now this normal and this tangent, this velocity is tangent to the circle, no? This tangent and this normal becomes 90-degree. So if this is 90 minus theta, the angle between velocity and horizontal is nothing but theta. So the horizontal component of velocity is nothing but v cos theta. V cos theta. From our earlier equations we got v is equals to under root gh by 3. Okay, and cos theta is equals to 2 by 3. So therefore velocity at maximum height, velocity at maximum height, velocity at maximum height, wait, wait, velocity at maximum height, my pin got caught, height AGIGHT, okay, is equals to v cos theta. Okay, or is equals to, I'm writing the value of cos theta first due to convenience, into gh by 3. So this is the velocity at maximum height. Okay,